Okay, here's the 2010 ordinary level question B2. Okay, so it's a greenhouse and a compost bin attached here. Okay, so there's your elevation, there's the plan, and we need an auxiliary view. Okay, so it says A is draw the given plan elevation. If you have the question out in front of you, this will be handier for you. Reading A now, and B, draw an auxiliary elevation of the greenhouse and compost bin, projected from the plan, right? Projected from the plan, which will show the true shape of surface A. So it's like a normal in SolidWorks. That's the viewing direction. If you look, there's an arrow. It's actually down here on the question. It's kind of pointing that way. But so the surface here A is the one we're worried about. So there it is on plan. It's just a rectangle. But as you can see, it's a longer line here. So we need the true shape of this surface. And how you find it is you always go 90 degrees. So my arrow here is actually 90 degrees. If I join in that way, that is 90 degrees. So I need to view up this way. And because this is 45 in here, which was drawn here, okay, that's 45 degrees. If you go up here, this is 90. So therefore I can go off at 45 or there. So I'm drawing the entire drawing up here at 45 degrees. So all you do is first project all the corners up. Okay, I project them all up. Okay, let's pick an XY. So the where you position your new XY or new ground line off here for this auxiliary elevation, okay, is anywhere really as long as it's not on top of this drawing. So that's the last point of that drawing. That's as far as close as I can get. So I'm just going to move out a little bit like that. So this is the XY here. That's the ground. And this is called X1, Y1. It's a new ground, and we're shifting our whole drawing up to that side. Okay, and this guy goes up. So all the corners of your plan go up at 45 because this here is at 45. That was in at 45 there. 45 degrees. So if that's at 45 degrees, then 90 degrees to it is that way. But you can also flip your set screw that way, and that's a longer edge. That's why I'm doing that. And there you go. So there's that. Is that all my corners? No. There you go. Okay, so if you look at surface A here, okay, now I'm going to rub out the few details here just to clean up the drawing, okay? I'm just going to keep it more basic. Now, if you look at surface A here, okay, it's a rectangle here made up of 4, obviously, sides, okay, rectangle, and in the plan it's just represented by a single line. Okay, so looking down an edge of it, So let's just go 1, 2, 3, 4. Now let's find out where those are in the plan. Okay, well then it's not the back, we're talking about the front. So 2 here is at the top and 3 is at the bottom. So we always, when we're looking down, we always order the points if they're in line with each other. They're in line with each other. When you're looking down, they're on one edge. You order them like that, 2, 3, because that's the one you see first, and then that'll be in the bottom. 1 is on here, okay, because this is surface A. This is the front of it, okay. There it is there. And that is 1, and then at the bottom one is 4, so that's 4. So let's get 1, 2, 3, and 4 now. Okay, so the beauty of an auxiliary elevation going up this way is that it's still an elevation. So it's an elevation, and this is auxiliary elevation. So an auxiliary elevation, or aux, I'm just going to write aux for short, it's short for auxiliary, and elevation, they use the exact same height. So if something's 50 here, it's 50 there, high. Okay, the widths will change. So these widths are no good going across ways, but going up from the XY. So anything that goes up from an XY is the same going up from an X1, Y1. So the heights of 2 and 1, so 4 and 3 are on the ground. So let's find 4 and 3 because they're on the ground. Oh, I missed a line. So going up this way, 4 is on the ground. So I just travel up till I hit the X1, Y1. And there's 4, and obviously it's up taller than that, so I'm going to go up there. And 3 is always on the ground as well. 3 is on the ground, 3 is here, so I go down here and I follow it. There's 3. Okay, not very well marked, but anyway, there's 3. And 2 and 1 are the same height. Now, we can use a compass or we can use a ruler, doesn't really matter, but because it's an even measurement, we'll call it, so that's 30 up there, okay? Things after moving, is it? There. Now, so that's up 30. So if it's 30 vertically, if it's if anything that says is a height here is a same height here. That's the beauty of an elevation, auxiliary elevation. They're always the same height. Widths will change. So going across measurements across that way, it won't be the same. But up from the XY, yes. So whatever height 2 is from above 3, it's the same in the auxiliary elevation. So that was 30. So therefore it has to be 30 up here too. Okay, and because 4 and 3 are the same height, we can go parallel to our XY because that's our ground on our elevation. The 4 and 3 are horizontal and 1 and 2 are horizontal. And in our auxiliary, if that's now the ground and 4 and 3 are on the ground and 1 and 2 are parallel to it. Okay, so that gives us corner 1 and that gives us corner 2. So that's 30 up there and that's 30 up there. So that now is surface A. Okay, so that's the crux of the whole drawing. That's what they're looking for. That's the whole point of the drawing is to actually find this. Okay, but obviously there's more to the drawing than that. The whole crux of the drawing is to do that, and I'm going to just heavy it in. Okay, so if I shade in there, surface A very gently, and then there. So now you know they're the same thing. Okay, you can figure out that much. Now, and you'll notice here that the widths are different. So on this view now, this was only 30 wide, so it's a square, and this view looks like a square. But here it's actually 42 wide. So the widths aren't the same, but the heights are. And if you look along here, this is actually 42 as well. So that's the true length of the line. We'll say 1, 2, or 3, 4. These lines, and also it's and this is the true shape of the whole surface. So that's what it really looks like. It's a rectangle. It looks like a square here. Actually, in reality, it's a rectangle. And you'll see in the 3D view on the drawings that it's actually a rectangle. Right, now it's just a case of drawing the whole rest of the drawing. Okay, now I just forgot to bring down the doorway points there because they'll be needed, and I'll bring them up as well. So everything has to get brought up at 45. That's basic because this is what's 45. That's what the rule is in this drawing. Other drawings it might be 30 degrees or 60 degrees. It depends on whatever slope this is. It's usually going to be 45, 30, or 60. That's it. That's the only way they ask it in the ordinary level exam. Let's find the back corners here. Well, they're in line with 2, so they're out along here. Okay, so if this here, if 2 here and 3, okay, and the back here at the top, so 2 and 1 and 2 are up at the top here, and the back is at the same height. Well, then these two lines come up, and they're the same height as 1 and 2. So I'm bringing them across like that. So that's actually the back there and the back corner there. That's those two corners there. They're the same height as 1 and 2. You can't see them in the elevation, but you can in this. Right? And that gives you this line here. Okay. And that there. Now, there is a back edge inside here that we don't see. Okay, we'll get to that in a minute. Let's just draw the front face of this. Okay, I'm just going to start giving them letters now because it's gonna get confusing. But we'll P, Q, and R is here. Okay, it's in line with 4, and just S and T. Okay, so it's P, Q, R, S, T. It's 5 points. There's P on the plan. We're talking about the very front of it now. There's Q and R. Q and R are in line with each other, and S and T are in line with each other. T is on above, so T comes first, and then S. So if you have 2 points in line with each other, you call the first one first, then a comma, and then a second one. So T and then S. Right, let's find them. So first things first, we have the line for P. So that's the center of it. So that's coming up there somewhere, and it's whatever height. The height doesn't change. So that was supposed to be 80. Oh no, it's not supposed to be 80, that was 60, and then we ended up at 30 degrees, so whatever height it is, it's actually 80 feet. Now in this case, I'm going to use a compass because it's an uneven measurement, okay? So a compass can also transfer measurements around a drawing. So we stick the compass on the ground, and go up to P, tighten her down like that. Okay, set the compass to the height of P, and then follow P up from the XY, and there it is. P. Now, we know that there's a ridge here going to the back. So there's a point in the back, and so we just use a horizontal line here. Going back over there, we don't know where it is yet, we'll worry about it. So there's the horizontal line. Actually, the back of it is here. So if we bring that up, it's the same height as P, the front. P, in the front of the ridge of the roof is going to be the same height front to back. It's not a sloped roof or anything, or sloped ridge. So that's the back of it there. Okay, let's find Q. Q is up 60, we know that because the measurement of the drawing told us. So that's up 60. Therefore, going up from Q here, there's Q. Right, well, there's R's on the ground, so actually if we follow Q and R here, that's R between my rating, and that's S on the ground here. And P and Q are above them, and they're above 60. So T is above 60. And because I've marked it there and I know it's the same height somewhere across there, I can go again parallel to my XY line again, so at 45 across like that. So that's actually our Q, I mean, here. So there's P, there's Q, and actually we give him a 1, we call him 1, okay? P, Q, P1, Q1, there's R1 on the ground, there's this one on the ground, and T1 is here, okay? And then we just draw the slope of the roof. The way my young friend in the background gets very excited. There we go. There we go. So there's the front shape there. Sorry, there's the front shape, and there it is squashed up on the auxiliary view. Now you'll notice as well that there's the doorway, and all I did was we know they're in line with T and Q, so there's T and Q. So you can actually see it there. When I brought up the two sides of the doorway, I brought them down to the plant, and I brought them. You can actually see the shape is already outlined there. So all you have to do is head it in. Okay. What are we at? 11 minutes. Okay, not too bad. There we go. Okay. You'll have an hour to draw something like this. Okay, and I've mostly done 11 minutes besides the setup, so you'll be fine. In the exam, you'll be fine. There's the back of it, and it's the same shape at the back here. Okay, so the back corner comes up, and that has to be in line with P, T, and Q, because these four corners are the same height up here. Okay, I won't label them. But there's the back corner is going to be the same height as T. Right, going along here, so you go up. That's one. Okay, and there's the outer back corner. And so let's actually bring that line across. And there. Okay, so there's that same shape again there. Okay. It's out there now. Oh yeah, I'm that there. I was out of it. That's not the point. Okay, it's over here. Now we can come back here and draw this one. But our problem with the other back edge is that's actually hidden. When you're looking in here, a lot of this, anything behind the slope of the roof on this side is hidden, okay? So therefore, that's going to be hidden detail because it's blocked, the other edge. Okay, and so is this one. It's all hidden. But the front edge is okay here. And this edge now is partially hidden, so it comes down to here, and then I told you there was hidden detail there at the back edge. Okay, which is this guy here. Alright, and there. And I think that's it. That looks finished to me. I don't see any edges, so I need the edges either solid or dotted or partially. So that's your surface A. The whole point of the drawing is to find the true shape of that surface A, all from there. And the direction you draw is given from whatever surface A is here on the elevation. It's usually it's always a single line in the plan, and whatever angle that is, you go at 90 degrees to it there. That's everything. So the whole, all those are at 90 degrees to whatever that is. So the rule isn't always, it is always usually it's 45, 60 or 30 degrees. So it's either, you know, it's there's only a couple of different slopes to use. So the view will be tilted one of three basic ways. Alright, so there's the finished drawing. I'd like you to have a go at that, and then also attempt the next drawing then. Thanks.